Now that we've taken a look at what fractions are and how we can simplify them using equivalent fractions, we're ready to take a look at how we can multiply fractions. To get an idea of how we multiply fractions, we're going to start with a picture to represent 2/3 times 4/5. Now we can think about area like a rectangle because base times height represents the area of that rectangle. And so if I were to take 2/3 going one direction and shade 2/3 of this rectangle, that would be 2 sections out of 3. And if I go the other way and shade 4/5 of the rectangle, that would be 4 sections out of 5 going the other direction. And what you noticed happened is we end up with double shading here in the top left corner. And notice that double shaded area is 2 high and 4 long. 2 times 4 is 8. Out of the entire box, now you see is 3 high and 5 long. 3 times 5 is 15. And so we end up with 2/3 times 4/5 is 8/15. Noticing that we multiplied across the top, across the numerators, to get the small double shaded box, and multiplied across the denominators to get the size of the entire box. So what we're going to do to multiply fractions is we will multiply across. So, for example, if I have 7/11 times 3/5, I can multiply across. 7 times 3 is 21, and 11 times 5 is 55, and we've got our solution for this multiplication problem. But multiplication is unique in that while we multiply across, what we can also do is reduce first, then multiply. In other words, if I have 6/14 times 35/12, we can reduce. The 6 and the 12 are both divisible by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. 14 and 35 diagonally can also be reduced. They're both divisible by 7. 35 divided by 7 is 5, and 14 divided by 7 is 2. And then I can use these reduced numbers to multiply across. 5 times 1 is 5, and 2 times 2 is 4, and I get 5/4. And that was much easier to do than multiply those larger numbers. So whenever possible, we're going to reduce first and then multiply across. We can reduce anything on top with anything on the bottom. Another thing to watch out for is working with whole numbers. Let's say I've got 3/8 times 20. When we're working with whole numbers, I can make that whole number into a fraction by putting it over 1. Now I can reduce. 20 and 8 are both divisible by 4. So 8 divided by 4 is 2. 20 divided by 4 is 5. And now I can multiply across. 3 times 5 is 15. And 2 times 1 is 2. And we get 15/2. Let's try one more. Let's try 35 times 6/7. Again, I can treat that 35 as a fraction by putting it over 1, and then reduce. 35 and 7 are both divisible by 7. 35 divided by 7 is 5, and 7 divided by 7 is 1. Multiplying across, 5 times 6 is 30. Over 1 times 1 is 1. And of course, we can reduce 30 over 1 to just 30, because dividing by 1 doesn't really change the value. Let's see if we have room for one more example in here. Let's do a problem with variables. Let's do 30a over 3b squared times 21ab over 10. Well, with the numbers we can reduce. For example, the 30 and the 10 are both divisible by 10, leaving 3 and 1. The 3 and the 21 are both divisible by 3, leaving behind 1 and 7. For the letters, we see a b squared on the bottom and a b on top. 1b can divide out of the top, leaving 1b remaining on the bottom. So putting that all together, when I multiply across, 3 times 7 is 21 for the number. And a times a, because we multiplied a twice, that's a squared, over 1 times 1 is 1, leaving just the b, and we have 21a squared over b. So that's how we multiplied with fractions. We multiply across. If possible, we reduce first and then multiply.